Hi everyone, welcome. Are you feeling the pressure of the upcoming GCE exams? Don't worry, you are in the right place as far as chemistry is concerned. In this video, I'm going to break down the essential concepts you need in the topics, the fundamentals of the periodic table and the atomic structure. And after that, I'm going to put your knowledge to test by giving you practice exams questions, the types that usually show up during exams. Grab your jotters, your pens, your calculators, and let's get started. The periodic table is divided into groups and periods. The vertical columns are called groups, while the horizontal rows are called periods. There are 8 vertical columns on the periodic table, corresponding to 8 groups. We have the group 1, the group 2, group 3, group 4, group 5, group 6, group 7, and of course we have the group 8 element. Elements found in the same group of the periodic table have the same chemical properties. Like group 1, the group 1 elements, they have the same or similar chemical properties. Group 2 elements, the same or similar chemical properties. Again, these groups we are seeing here, there are some groups that are very special. The group 1 element, the group 2 element, the group 7 element, and the group 8 element. The first 2 and the last 2, they are called special groups on the periodic table. And as such, we have given them special names. The group 1 elements, we call them the alkali metals. The group 2 elements, we call them the alkaline earth metals. The group 7 elements, we call them the halogens or salt formers. And the group 8 elements, we call them the noble or inert gases. We call them noble or inert gases because they don't take part in chemical reaction. Now, let's go to periods. The horizontal rows are called the periods. These are the horizontal rows of the periodic table. We call them periods. We have period 1, period 2, period 3, and period 4. There are altogether 7 periods on the periodic table, but we are having 4 here because we are dealing just with the first 20 elements of the periodic table. Elements in the same period of the periodic table have the same number of valence shells. For instance, lithium and beryllium, they have 2 shells because they are found in period 2. Sodium and magnesium, they have 3 shells because they are found in period 3. While potassium and calcium has 4 shells because they are found in period 4. If you want to move further, we'll go to period 5, in which elements in period 5 has 5 shells. Now, let's look at something here. These numbers are written down here. Under group 1, I've written 1. These are the valences. All the elements in group 1 of the periodic table have a valence of 1. Group 2, they have a valence of 2. Group 3, they have a valence of 3. Group 4, they have a valence of 4. When we reach 4, the numbers start dropping. From 4, we go back to 3 again. They start dropping accordingly. Group 5 elements, they have a valence of 3. Group 6, valence of 2. Group 7, valence of 1. And group 8, they have a valence of 0. They don't take part in chemical reactions. Look at it very well. Group 4, they have a valence of 4. The numbers start dropping accordingly. It starts from 1 right up to 4, and from 4 it starts dropping right up to 0. There's an explanation for this which is not necessary in this video, but it is also essential that you know these valences, because these valences are going to help us in writing the chemical formula of compounds as we proceed. We have also seen that I've numbered these elements. The first element on the periodic table is hydrogen, the second is helium, and so on and so forth. These numbers is accordingly. These are the first 20 elements. That's what I've numbered from 20. But these elements with these numbers we see here, they are not just numbers as per serial numbers. They can be serial number, but in chemistry We call them atomic numbers. We call these elements the atomic numbers of elements. And the atomic number of element gives us the number of electrons that element has. For example, hydrogen has just 1 electron, helium has just 2 electrons, calcium has 20 electrons, chlorine has 17 electrons. So we're saying that the atomic number of an element is the same as the number of electrons that element has. It is very, very important. We should note it. The atomic number of an element corresponds to the number of electrons that atom has. It is very, very important and essential that we should note this, because when we are dealing with electronic configuration, which we are going to see subsequently, we are going to see the importance of this atomic number, which corresponds to the number of electrons. Now, let's dive into the basics of the simple atomic structure. An atom consists of a central nucleus surrounded by paths called shells, energy levels, or orbitals. This is the nucleus of an atom. And inside the nucleus of an atom, we have subatomic particles. Normally, there are 3 subatomic particles. We have the protons, we have the neutrons, and we have the electrons. The protons and the neutrons are found in the nucleus of an atom. The protons and the neutrons are found in the nucleus of an atom, and they are collectively called the nucleons. The electrons are found on the shells, orbits, or energy levels, locations of the 3 subatomic particles. Protons, they are found in the nucleus. Neutrons, they are found in the nucleus. They are collectively called the nucleons. Electrons are found out of the nucleus on paths called orbits, shells, or energy levels. The first shell in an atom is called the K shell. This is the first shell. The innermost shell is called the K shell. This shell takes a maximum of just 2 electrons. The second shell is called the L shell. This L shell takes a maximum of 8 electrons. The third shell is the M shell and takes a maximum of 8 electrons as well. And of course, the last we have the N shell that takes a maximum of 8 electrons too. It's good to note the number of electrons each of these shells takes, because it's going to help us in writing the electronic configuration of an atom. The charge of the proton is positive. The charge of the neutron is neutral, meaning a neutron has no charge. It is 0. It doesn't have a charge. The charge of an electron is negative. It's negative. The function of the proton and the neutron in an atom give us the mass of that atom. They are responsible for the mass of an atom. If you want to obtain the mass of an atom, you simply add the number of protons and the number of neutrons. You are going to have the mass of that atom. The electron functions in giving the volume of an atom. That's the function of the electrons in an atom. It gives us the volume of that atom, atomic volume. Now let's quickly rehearse ions. An ion is a species with a positive or a negative charge on it as a result of loss or gain of an electron. If I have an atom and I add or subtract electrons from it, that gives me an ion. When an atom gives electrons away, donates electron, that atom becomes a cation and it acquires a positive charge. When an atom receives electrons from another atom, it becomes an anion and it acquires a negative charge. For instance, sodium ion. Sodium has given up 1 electron. That's why it's having just plus, meaning magnesium has given up 2 electrons. That's lost 2 electrons. Let's come to sulfur. The sulfide ion. The sulfide ion, meaning sulfur, gain 2 electrons, 2 extra electrons. Nitride ion, meaning nitrogen has gained 3 extra electrons. We are going to see it in the examples. Just know that cation is positive, a positively charged ion, cation. Take the T in cation as the positive charge, and then anion should be negative. Cation gives electron and they are positively charged. Ions gain electron and are negatively charged. Now let's look at example in writing the electronic configuration of elements. We said the shells were divided into the K shell, which is the innermost shell, the L shell, second innermost, the M shell, the third, and the N shell. Let's look at the case of sodium I said earlier. Sodium has 11 electrons. Let's represent sodium, the nucleus of sodium, with the symbol of sodium. This is the symbol of sodium. Latin name of sodium is natrium. That's why we're having Na. But in English, we call it sodium. This is the K shell. We said the K shell takes a maximum of 2 electrons. We put the 2 electrons, 1, 2. We move to the next shell, the L shell, and we said it takes a maximum of how many electrons? 8 electrons. We start distributing 1, 2, 3, 4, 5, 6, 7, 8. Note that we are pairing electrons. Electrons occur in pairs. That's a topic on its own for another day. We have given 8 electrons here, and we are left with how many? 2 here plus 8 here is 10. So just 1 electron is left. On the M shell, we put the 1 electron. We cannot continue the next shell because our electrons are finished. So we end here for the case of sodium. For an element that has, let's say 20 electrons. Let's go cancel 20 electrons. We are going to extend right up to the N shell. Now, in writing the electronic configuration, we start distributing. The innermost shell had how many electrons? 2 electrons. This is 2. The second innermost, the L shell, has how many electrons? 8 electrons. And then the last shell, of course, has 1 electron. And this is the electronic configuration of sodium. This is the electronic configuration of sodium. 2, 8, 1. The numbers are separated with commas. Take your pen, your jotter, and then try the electronic configuration of calcium and see if you get it. Also, the electronic configuration tells us a lot about an atom. Look up here. How many shells has the electrons occupied? That's occupied 1, 2, 3. 3 shells. This is it, 1, 2, 3. Meaning sodium is found in period 3 of the periodic table. The last shell is called the valence shell. How many electrons are on the valence shell, which is the last shell? We have just 1 electron, meaning sodium is in group 1 of the periodic table. As you do the exercise for calcium, also indicate the period and the group in which calcium belongs. There are a lot of multiple choice questions always coming from this section. Writing electronic configuration, indicating the group and the period. Here is the secret I'm going to be revealing for those who are still following up. Look at what we have here. Can you read this? A pen. A pen. A stands for atomic number. P stands for number of protons, E stands for number of electrons, and N stands for number of neutrons. A in an atom is always equal to P. P in an atom is always equal to E. And E in an atom is equal to, at times, not always, at times it is equal to N, and at times it's not equal to. So this is where our problem lies. We need to always calculate this man here. We cannot assume. But you see, for this one, we can assume. But this man right here, we cannot assume. We always do the calculation. When we are dealing with the example, this acronym is going to help us a lot. A pen. So never forget that. And also, we might be asked to calculate the mass number of an atom. If you remember earlier, I said if you want the mass of an atom, you add the number of protons and the number of neutrons. That's what we said earlier. As simple as that. When you are dealing with ions, you must be very, very vigilant. Ions can either gain electrons or give up electrons. That's what we agreed. When you calculate the number of electrons in an exercise, you have to look again. Is that atom an ion? Has it been ionized? Has it gained electron? If it has gained electron, you add the number of electrons gained. If it has given off electron, you subtract the number of electrons given off. Let's answer a mock question and a GC question related to this. Let's try to test our knowledge by looking at this question. This is mock 2022 question 1. It reads, the table below gives some information about 6 elements A to E. Using the letters A to E, answer the following questions. Elements A, B, C, right up to E. Atomic numbers are. And then the electronic configuration. They have given us the electronic configuration here. Now, question 1. Give the atomic number of C. Where's our C? This is our C here. Now, let's look at the information we know about the C. We know the electronic configuration of C. So, C has 2 electrons in the innermost shell, 8 in the second innermost, and 4 on the valence shell. If we sum all of this, it's going to give us 14 electrons. So the number of electrons in C we have are 14. And if we remember very well, using this our acronym, we have 16 here, meaning for C, E is 16. And we know that E is equals to P, meaning P should be 16 as well. And A, which is the atomic number, should be 16. What are they asking us? The atomic number of C. So we are quietly going to write our answer as 16. Now let's go to sub A. Let's go to A sub 2. The electronic configuration of D. This is our D here. We are going to write the electronic configuration. What information do we know about D? The atomic number of D is 18. Atomic number of D is 18. And we know that electronic configuration is written using number of electrons. We also know that atomic number is the same like number of electrons. From this our acronym, they have given us the atomic number, which is equal to the number of protons and which is equal to the number of electrons, isn't it? This is it here. The number of electrons is also what? 18. The number of electrons is 18. A is 18, P is 18, and E is 18. It is not an ion. If it is an ion, we'll start adding or subtracting. Since D is not an ion, we work with it as it is. We have 18, 18, 18. Now, let's start writing. The innermost shell, we said it takes a maximum of 2 electrons. The second innermost takes a maximum of 8 electrons. How many electrons do we have? 2 plus 4 gives us 10. We are still left with other electrons. Let's continue. The third shell takes a maximum of 8 electrons still. Are we following up? because we have 18 electrons and we are going to be distributed according to shell. The K shell 2, the L shell 8, and the M shell 8. Let's sum these numbers. 2 plus 8 gives us 10. 10 plus 8 gives us 18. And that is it. What can we say about this? This is an aside though. What can we say about this atom? This atom D is found in period 1, 2, 3 of the periodic table and in group 8. C is found in period 1, 2, 3, period 3 and group 4 of the periodic table. Hope you are following up. B. Which of these elements does not form compounds? Element reason. From what we explained about special groups. Group 1 element, the alkali metals. Group 2 elements, the alkaline earth metals. Group 7 elements, the halogen. And group 8, the noble gases. They are called noble or innate gases with a valency of 0 because they have a completely filled subshell and they don't take part in reactions or in formation of compounds. So our answer is D. Have we seen D? D is found in group 8. Group 8 elements don't form compound. They are not reactive because they have a completely filled valence subshell. So our answer here is D, reason. Completely filled valence shell. Completely filled valence shell. Okay. Question C. Which of the elements is a halogen? What did we say are halogens? Which group of the periodic table do we refer to as halogens? We have it here. We had mentioned it earlier. Can you guess the answer? If you are following up, you should know the answer by now. We have it here. These are the special name. Group 1, the alkaline metals. Group 2, the alkaline earth metals. Group 7, the halogens. And group 8, the noble gases. So they are asking us which of the elements is a halogen, meaning which element is found in group 7 of the periodic table. Now, for us to know the element that is found in group 7, we can write the electronic configuration, isn't it? Of course. If we write the electronic configuration of this element, this is the one that we don't know, element B, we are going to be having 282. Since we have 12 here, we have 2 in the innermost shell, 2 electrons in the innermost shell, 8 in the second innermost, and we are left with 2. So this element cannot be a halogen. Now let's come to E. If we write the electronic configuration of E, we are going to have 2 electrons in the innermost shell. Let's just write it. For this one, since it is 12, we are going to have 2 in the innermost shell, 2 electrons, 8 electrons in the second innermost, and we are going to have 2 electrons in the valence shell. So this element is found in period 3, group 2, not group 7. So that's not the answer for us. This one we have written as 288, which is a noble gas group 8. Now let's come to this one. It has how many electrons? 17 electrons. We are going to write 2, 8, how many electrons are remaining? 7, and then 7. Yeah. Element E is found in period 3, group 7, and the group 7 element are called the halogens. So we are going to write here element E, because they say we should use only the letters. So element E is a halogen. Okay. Now let's continue. Write the sub 2, C sub 2. Write a balanced equation between hydrogen and the halogen in C1 above. This is where the issue of valencies come in. Valencies. Write a balanced equation between hydrogen and the halogen in C1 above. We are going to write hydrogen. This is our hydrogen. This is the symbol of hydrogen. When you are writing chemical equation, you use symbols. Hydrogen plus halogen. What was our halogen? E. Hydrogen plus halogen will give us X. Let's do it here. Hydrogen plus E. E is our halogen. Let's look at the compound that will be formed. That periodic table that we have here, this is our periodic table. Let's look at it again. Hydrogen is found in group 1 of the periodic table, meaning the valency of hydrogen is 1. E is a halogen, meaning it is found in group 7. The valency of group 7 element is 1 as well. 1. And in writing the product form, you have to swap the valency like this. Are we seeing? You take this one and give to this one, take this one and give to this one. The valencies of hydrogen and the valency of E, which is a halogen, they are the same. But as you are answering other questions, you might encounter a situation in which the valencies are different. So when you swap the valency, first of all, write the first element, which is hydrogen. When you write the hydrogen, you write the valency, the swapped valency, this one. You write 1 here. You write the next element, E. And you write the swapped valency, the new valency, which is 1 as well. So see, it is 1, 1. There's no need writing. If the numbers say we are different, when the valency is 1, just forget about it. But if it is not 1, make sure you write it. Where it is 1, 1, 1 cancel out now. This one cancel this one. If it is 2, 2, 2 cancel out. But if the valencies are different, the numbers are different, like for instance, I have 2 and 3 or 3 and 2, you leave them as they are. But when they are the same, they cancel out. So the product form will be He. That is not all. You go back to your element. Hydrogen is a diatomic molecule, meaning hydrogen combines with another hydrogen to form a molecule. The atom of hydrogen is very, very unstable, so it has to combine with another atom to obtain stability. So it occurs as a diatomic molecule, and this is how we write diatomic molecules. 2. The halogens, they also occur as diatomic molecules, so we are also going to write a 2 here. Every diatomic molecule has a small 2 beside it. It's good that you study a periodic table and know which elements are diatomic molecules and which one are not. Nitrogen is a diatomic molecule. Oxygen is a diatomic molecule. The halogens are diatomic molecule. Hydrogen is a diatomic molecule. Now this is what we have here. We have 2 hydrogen, 2 halogen. But look at here. We have just 1 hydrogen and 1 halogen here now. So I have to balance the equation. They say we should write a balanced equation. Since we have 2 hydrogen and 2 halogen here, we need to balance it. We have 1, 1 here. You cannot come in between a compound and you write a number in between them or behind. You always balance equation writing numbers in front. If we write 1 here, it makes no difference. It is still 1, 1. Let's try 2. If we write 2 here, this 2 like this goes for all the elements in that compound. This 2 affects hydrogen and it affects the halogen. Now let's check. 2 hydrogen, 2 halogen, 2 hydrogen, 2 halogen, and we can dance. So this is our balanced equation. We come here and then we write 2, 2, 2, 2, and that is our balanced equation. It goes same with other elements. Let's proceed. We go to D. Write the formula of the compound formed between B and E. B and E. We remember our B. We remember again that our E was the halogen. Our E was the halogen. B. The formula of the compound formed between B and our E. This is our B here plus our E equals to, to give dash, we don't know. Our B is found in group 2, have a valency of 2. 2. And the halogen valency of 1. We remember our E was a halogen. This one and this one. Now we write our B. The new valency is now 1. We write our E. The new valency is 2. This is a compound form between B and E. If you are writing the formula of the compound form, you don't need to know if it is a diatomic molecule or not, except you are balancing. So this is the formula of the compound formed between B and E. And we write that using the valency. So we have B. If you want to write the 1, you write. If you don't want to write it, leave it out. When the valency is 1, it doesn't make a difference writing or leaving it out. And then 2 and above you must write. And that is Z. Identify the bond type in the compound formed in D1 above. Bond type, bonding. The bond type formed in D1 above is ionic bond. Ionic bond. That's the bond type formed. This mock 2025 question 1. The table below gives information about the atom X and the ions Y3 minus and Z2 plus. Cation and anion. Remember? Let's look at what we have here. Atom X has as atomic number 23. This one was not given. This one was not given. This one was given. Number of electron was 11. Number of neutron was not given as well. Like I said, I started answering the questions already. Now, complete the table by giving the values of A to F. A. On the atom X, what do we know about the atom? We know the mass number and we know the number of electrons. Mass number, like we said, is the sum of the nucleons. If we have the mass number as 23, mass number the sum of the nucleons. Let's just use this our secret. Atomic number equals to proton number equals to number of electrons and number of neutrons. We have to give the number of protons. Are we saying we have to give the number of protons? And if we have number of electrons as 11, according to what we have here, number of electrons as 11. Here is 11. Number of protons should be 11. And atomic number should be 11 as well. So what we are going to write here as the number of protons is 11. Are we following up? Because A is equals to P, which is equals to E. All of this one, they are the same. So we are going to write 11 here. Now let's go to number of neutrons, N. We cannot assume that N is 11. No. It can be this one, it can be this one. Is it equal to or is not equal to? Let's calculate and see. How do we calculate the number of neutron? The number of neutron is the mass number minus the number of protons. If you make the number of neutrons the subject of the formula here, you have number of neutrons as mass number minus number of protons. What is the mass number? 23. What is the number of protons? 11. 23 minus 11 gives us 12. So number of neutrons should be 12. In some cases, you calculate and everything is the same. This one will be equal to this one, this one will be equal to this one, and this one will be equal to this one. Everything here will be the same in some cases. But it's good to calculate. But in this case, we have seen here is different. Number of neutrons here is 12. So it is always good to calculate this particular man here. Let's go to Y. Y is an ion. Note it. Y is an ion. a negative ion. What is the name given to negative ion? Anion, because they have gained electron. How many electrons has Y gained? 3 electrons. So when you are calculating number of electrons to Y, we are going to add plus 3. Let's look at it. Mass number of Y is 14. Number of protons has not been given. Number of electrons has not been given. Number of neutrons has been given. So we need to calculate number of protons and number of electrons. Now, they have given us N, and they have given us mass number. Mass number is 14. If you calculate that, if you have your mass number, you can calculate number of protons, isn't it? You just take this one minus this one. Mass number minus number of neutrons now to have your number of protons. It is the neutrons and the proton that gives us the mass number because they are found in the nucleus. Since we know the number of neutrons, we can subtract and we'll have our number of protons. If we take 14 minus 7, it's going to give us 7. 14 minus 7 is going to give us 7. So our proton will be 7, meaning our C here would be 7. Are we there? Our C here is 7. That's our C. It is correct. You can also verify your answer. This one and this one will give you this one now. The nucleons will give you the mass number. Now let's go to number of electrons. Please pay attention here. That's why I decided I should answer this question, because of this D and F. Let's go to our number of electrons. Let's use, since we have number of protons as, our number of protons here is 7. Atomic number should be 7 still. Number of electron 7. Look at it, is 7 here, but we still have a problem. It is an ion that has gained, it is an atom that has gained electrons. How many electrons? 3. Are we there? We follow this row still. 7, 7, 7. It is an ion. We have to add or subtract electrons. What are we doing? We are adding electrons because this atom has gained electrons. How many of them? 3. So we are going to have 7. We are going to have 7 plus 3 here. We are going to have 7 plus 3 here. Plus 3 because it has gained electron. Normally, it's supposed to be 7, 7, 7. Following this, our secret. But I said that we should pay attention when it comes to ions. Cation will subtract, anions will add. It is an anion, we are adding 3 electrons because it has gained 3 electrons. This is it. So we write our 7, 7, but when we reach for number of electrons, we add plus 7. So how many electrons will be there together? 7 plus 3, which is give us 10. So we have 10 here instead of 7, 7. So we are going to have 10 here instead of 7 because of these 3 extra electrons gained. So our D will be 10. Now let's go to our E. Our E, we follow the same procedure. Z2 plus. Now they want us to give the mass number. Mass number is the sum of the particles in the subatomic particles in the nucleus of an atom. The particles that are found in the nucleus of an atom that determines the mass number of an atom are the protons and the neutrons. I said that. So if you sum this one and this one, it's going to give us the mass number, which is 12 plus 12. This is it. Mass number equals the number of protons plus number of neutrons. 12 plus 12 will give us 24. So our E is going to be 24. Now pay attention here again. We now have a cation. Alright, if you follow this our table, we have number of protons as 12. So P here is 12 on this question. On this one, P is 12. Number of proton is 12. E should be 12 and A should be 12. Normally be like this. But now it is a cation. It has given up 2 electrons. We are going to subtract minus 2 electrons from the number of electrons because it is a cation. And we will subtract, we'll be left with 10 electrons. So our F here is still 10. And here we still have 10. Hope it's clear. We added here because Y gained 3 electrons. Identify the cation and the anion. That one is as simple as we are seeing it. The cation is the one with the positive sign, which is Z2 plus, and the anion is the one with the negative sign, which is Y3 minus. It is as simple as that. Able to follow this video steadily and attentively, you'll be able to answer any question 1 in the GCE ordinary level. Most of them are always like this or something similar. They just play around with different figures and different elements. Also, let me know which topic you want me to cover in our next video. Remember to keep practicing, review your notes, stay confident, and good luck in your final exam.